Hey guys, I'm going to go over your statistics study guide. I would suggest that you do the study guide all by yourself first, and then come back to this video when you're ready to check or you have any questions. So go ahead and do that now, and then I'll start by going over question one. In this first section, we're differentiating or deciding the difference between a population and a sample. In question one, there's a survey of 2,541 American households. We discovered that 53% of those households have children. Since the whole group we're studying is the population, and that is American households, that would be the population, and the sample would be that 53% of households with children. Question two, we see that 85% of the student council, that's the whole, plans to attend the Thanksgiving parade. So since 85% want to attend the Thanksgiving parade, that's the sample. The whole group is the population. That's who we're taking this survey from, and that is the student council. Question three, it says on a flight to Orlando, 72% of the passengers are traveling for leisure. That 72% that's traveling for leisure is the sample because that's part of the whole group. The whole group is the population, which is everybody on the flight. Now let's look at question four. It says 17 children in Mrs. Johnson's class have brown hair. Since the population is the whole group, the population would be the children in Mrs. Johnson's class. The sample would be those children who have brown hair. In the next section, you should be able to identify a random sample. So we're going to match the statistical questions on the left. Remember, statistical question is one that has answers that vary. And we're going to match that to the random sampling method on the right. So we're going to actually skip number 5 for right now. I think it's a little more difficult. Let's look at number 6. It says, how do West Middle School students get home? Since we're talking about people getting home, we should be looking at the exits. We should be looking at the exit doors. And all the students who leave are asked their method home. That should be C. For question 7, it says, which lunch item is the tastiest? So we want to ask everyone in the cafeteria. So we should be looking at the cafeteria and looking at every 10th student who comes into the line to be surveyed. For 8, it says, where should the 8th grade go at the end of the year? Since we're looking at the 8th graders, we need to ask the 8th graders. So since we're looking at a number assigned to each 8th grader and then 25 randomly selected, that would be a random sampling method. Now for this first one, which we're doing last, it says, what's the best characteristic of a teacher? We just want to know about teachers and what students think about them. So we're randomly going to look at students. So putting random names into a hat and then drawing them out would be a good random sampling method. For the next section, we're going to be able to use data in these statistical questions to draw inferences about a population. This is where we set up those proportions. So number 9 is about an internet company randomly selecting 50 of its customers and asking them how many hours per week they use the internet. That randomly selected 50 people is the sample. It says of those surveyed, 28 of those people use the internet more than 15 hours per week. That 15 hours is not necessary for a proportion. We will look at the 28 people out of the 50 that were selected. Based on that data, if the company has 800 subscribers in total, how many use more than 15 hours per week? So let's set up our proportion with the fraction that we have already. I saw that 28 of the randomly selected 50 is a fraction. 28 is the sample, 50 is the total. And we're going to compare that to the 800 subscribers total. So I set up my proportion, and then I decide that the 800 subscribers is the total, and that needs to match the fraction on the left. So I'll put that on the bottom. When I've got it set up as a fraction like this in a proportion, I cross multiply to solve. So I circle the numbers across from each other and multiply. I got a really big number, 22,400, and I'm going to divide by the number that's left, 50. When I do that, I end up with my final answer, 448 customers, which is how many we can expect to use the internet more than 15 hours per week. We'll do the same thing for number 10. It says that 2,000 people are surveyed, and of the 2,000 people, 1,240 are planning to vote for candidate A. And then the question is asking about a percentage, about how many percentage points is that candidate leading. I'm starting with my fraction that I have. I have 1,240 out of 2,000. That is my part out of the whole, the sample out of the population. And since I'm comparing that as a percent, I'm setting up a percent proportion. And percent is always out of 100. Now, when I have it set up like this, I can cross multiply to solve. So multiply these two numbers and then divide by the 2,000. When you do that, you end up with 62% for candidate A. The question doesn't say how many percent of people vote for candidate A. They want to know how much candidate A is leading by. So we need to know how much percent is voting for candidate B. Since percent is always out of 100, I know that candidate B has 38% of the votes. And now I'm looking for the difference because it says by how many percentage points is candidate A leading. So I'm going to subtract those numbers. This is how I find that candidate A is leading by 24%. For the next 3 questions, we're going to use this table. And question 11 is giving me some totals. The table is a sample. and 11 is telling me the population. It says there's 280 sixth graders, 200 seventh graders, and the question is asking me about the people involved in the yearbook. So I'm going to start by looking at yearbook, and I'm going to look at the sixth graders. I see that there's 10 people in the yearbook out of their sample. The total number of people sampled is 10 plus 24 plus 6, which is 40 total. So 10 out of 40 sixth graders are involved in yearbook. We want to set up a proportion to figure out how many are involved in the whole class. Since it told me that 280 is the total, I'm going to put that number on the bottom of my new fraction, and then I'm going to cross multiply to solve. So I'm going to circle the numbers across from each other and multiply. I got 2,800, and I'm going to divide by the number that's left, 40. So which tells me that there are 70 sixth graders involved in yearbook. Now let's do the same thing for seventh grade. I got my first fraction, 18 seventh graders in yearbook out of the 40 that were sampled in total. And then that's going to set up a proportion out of 200 because there's 200 seventh graders total. Once I've set up my proportion, I'm going to cross multiply to solve. So I'll circle the numbers across from each other and multiply, and then divide by the number that's left. So I discovered that there are 90 seventh graders involved in the yearbook in total. Now the question asks me how many more seventh graders are involved than sixth graders. That's a question about difference, which is a question about subtraction. So 90 minus 70 is 20, which means that there are 20 more seventh graders involved in the yearbook than sixth graders. Question 12 says, what percent of sixth graders are involved in the yearbook? Well, I know how many are involved in yearbook. I just found that. There are 70 yearbook people out of the 280 total in the class. Now I'm going to set up a percent proportion. Since I'm solving for a percent out of 100, I'm going to cross multiply and then divide. When I do that, I end up with 25%. The other way you could do this is to take 70 divided by 280, and you would end up with 0.25. And if you're like me, you do it like that, then you move the decimal over 2 places because percent is out of 100. You move the decimal 2 places to the right, and you get the same answer, 25%. For question 13, it says the schools decides to drop any club in which less than 5% of the population signed up for. Should any clubs be dropped? So we just did yearbook and we realized that those were more than 5%. So we're good with yearbook. We're also good with student council because they have more members in the sample that we did. So we're fine with that. The one we should be concerned about is the jump rope club. So I'm going to look and decide how much of the population is in the jump rope club. And I'm going to do that using the sample. So I'm going to look at the sample of 6 of the 40 sixth graders that are in the jump rope club, and I'm going to set up a percent proportion to determine if that is more or less than 5%. After cross multiplying and dividing by the 40, I got 15% of people in sixth grade are in that jump rope club. So jump ropers in sixth grade, they're good. So now I'm going to look at the other smallest club, which is the seventh grade jump rope club, and I'm going to look at that sample of the population. So 2 of the jump ropers out of the 40 people surveyed total. Just like before, I'm going to set up my percent proportion. Percent is always out of 100. So I've got a unknown percent out of 100. And now I'm going to cross multiply to solve. 2 times 100 divided by 40 is 5%. Now the school has decided to drop any club that has less than 5%. Since the seventh grade jump rope club is at 5%, we're good. And no clubs should be dropped. For the next questions, we're looking at the measures of center. Those are mean and median. And question 14 is examining the number of dollars that 20 customers withdrew at an ATM. We're going to start by finding the average number of dollars. So to find the mean or the average, we're going to add up the total number of dollars and then divide by the 20 data points. So since there's 10 of the 20s, we're going to do 20 times 10 just to make our life easier. And then we're going to do 40 times 5 because that's, again, 40 plus 40 plus 40 and so on. So another 200 plus 120 plus 80 plus 200. Now we're going to take those numbers and add them up to find their sum, which is 800. So the number of dollars withdrawn is 800 total, and we're going to divide that by the number of data points. Since there were 20 customers, we're going to divide by 20. 800 divided by 20 is 40, which means the mean number of dollars withdrawn from this ATM is $40. To determine the median for the number of dollars, we're going to have to write all those numbers out on a separate sheet of paper, starting with the 10 20s, then the 5 40s, the 2 60s, the 180, and the 2 100s. Because there's so many data points, I always want to just double check myself and recount, make sure there actually is 10 20s and then 5 40s and so on. When I did that, I realized I actually had 11 20s counted out, so I'm going to take one of those off. Awesome. And now I can start crossing off one on either side until I meet in the middle. When I do that, I see that I have a 20 and a 40 in the middle. The rule is when you're finding the median and there's 2 in the middle, you're going to add those numbers and then divide by 2. 60 divided by 2 is 30. I also know the number in between these two numbers is 30. For question 15, we're looking at data that represents the average high monthly temperature in Denver, Colorado. If we're looking for the mean, we're going to add all the numbers together, and then we're going to divide by how many there are. After adding all these numbers, I get a sum of 768. Now I'll divide by the number of data points. There are 12 data points, so I'm going to divide by 12. And when I do that, I find that the mean or average temperature in Denver, Colorado is 64 degrees. Now to find the median, I have to start by lining up my data in order from least to greatest. So this is my new list in order from least to greatest. You'll notice I marked off each one of these as I put it down. That way I would keep them in order and I wouldn't forget about a number. Then I just go through and cross off one from each end until they meet in the middle, because the median is the number that's in the middle. So when I do that, I see 61 and 65 are both in the middle. So I'm looking for the number that's in the middle of those numbers, or I could find their average. So 61 plus 65 divided by 2 gives me a median of 63. For the next section, we're going to be able to find the measures of variability. In this case, that is the mean absolute deviation or the interquartile range, if it's a question about medians. So we're going to start with this 16 question about mean and mean absolute deviation. So the first thing we have to do is find the mean. So we're going to find the mean number of siblings by adding all these values and then dividing by the total number of data points. The sum of these numbers is 12, and since there are 6 data points, we're going to divide by 6 to get a mean of 2. And now when we look at deviation from the mean, we're looking at how far off it is. We're looking at the difference between the actual data point and the mean. So 3 minus 2 is 1, 2 minus 2 is 0, and so on. Now we have all the deviations from the mean. We're looking for the absolute deviation from the mean. The MAD has that word absolute, which should remind you of absolute value. That's just the positive version of these negative numbers. It's the distance each data point is from the mean. The only difference between these and these is that we just pick the positive versions of them. Now when we find the mean absolute deviation, we have to find the mean of the new set of numbers. So these absolute deviations, we're going to add all those up. So when we do that, we get a sum of 6. And again, to find the mean absolute deviation, to find that mean, we're going to divide by the number of data points. There were still 6. 6 divided by 6 is 1. So the mean was 2, but the mean absolute deviation is 1. Question 17 is got some data about the number of students in Monday's swim classes. We're looking for 3 things: quartile 1, quartile 3, and the interquartile range. This is a question about median. So step 1, with anything with medians, we want to order the number from least to greatest. Here's my new list, ordered from least to greatest, and I'm going to start by finding the median. There's 2 numbers in the middle, but since they're both 6, I know that the median is going to be 6. And I'm going to separate my data into the quartiles, keeping that 6 on that side and this 6 on that side. Because 6 was the median, that's going to split my data set into 2 halves. Now I'm going to find the first quartile, which is the median of the first half. The median of the first half is going to be 4. So that's Q1. And then Q3, I'm going to find the exact same way. So I see that Q3 is 8. The IQR is the interquartile range. The difference between Q3 and Q1, 8 minus 4 is 4. So that's the IQR. For question 18, we're going to do the same thing. This time it's just cost of orders at a Chick-fil-A drive-thru. Step 1, put these data points in order from least to greatest. Here's the new list. Now step 2 is going to be to find the median of the entire data set. 14 is the median of the entire data set. There's 7 numbers on each side of it. Now I'm going to take those 7 numbers on each side. I'm going to split them up. And I'm not going to include the 14 in either one of those halves. Now I'm going to look for the median of the first half and the median of the second half. That's how I find Q1 and Q3. So the median of the first half is 9, so that's Q1. The median of the second half is 21. And then the interquartile range, or the IQR, is the difference between Q3 and Q1. 21 minus 9 is 12. So that's the interquartile range for this data. For the last 2 questions, we're going to use measures of center and variability from samples to draw conclusions when we compare box plots, or in this case on 20, compare dot plots. So starting with number 19, we're looking for which statement best supports the data provided from the Gomez family box plot and the Smith family box plot for pieces of mail that we've analyzed. So we're going to look at each one of these in turn and decide if it's accurate or not. So A says the range of the data for the Gomez family is less than the range of the data for the Smith family. The range is the greatest minus the least, the maximum minus the minimum. So for the Gomez family, that range would be 10, and the range for the Smith family would be 8 minus 1, which is 7. So the range for the Gomez family is actually greater than the range for the Smith family, which means that it cannot be A. B says the data for the Smith family is more symmetrical. That means that it's about the same on either side than the data for the Gomez family. The Smith family is more symmetrical. The median is in the middle of the box, and there's about the same amount on each side, whereas the Gomez family, the median is more to this left side. And I know there's the same amount of numbers on each side, but it's not as symmetrical on the box plot. So we can already see that the answer is going to be B for this question. Just to make sure we're on the same page, we know it's not C because the median for the Gomez family is 6, and that is not greater than the maximum for the Smith family because the maximum for the Smith family is 8. 6 is not greater than 8, so we know it can't be C. For number 20, we can compare the median of these dot plots. I can see that the median for the first one at St. Mary's is at 7 after crossing off all these dots. I'm at a number between 8 and 9, which is 7. And I did the same thing for the St. Jude's Hospital, crossing off either side until I come to the two that are in the middle. The dots that are in the middle here are between 6 and 6.5. So the median would be 6 and a fourth, or 6.25 for St. Jude's. So I can already tell you that it's going to be B. The median weight at St. Mary's is greater than the median weight at St. Jude's. All right, guys, that's it. If you made it to this video, please let me know if you have any questions. Good luck on your test. Bye.